Hey, so finishing up on notes for we're now going to for 10.4b, we're going to look at the slope of a polar equation. So this will resemble a lot like slope of a parametric equation. To find the slope of a tangent line to a polar graph, r is equal to f of theta. We can use x equals r cosine theta and y equals r sine of theta and the product rule. So dy over dx, just like with parametric equation, we would do dy over dt over dx over dt. Well, now in terms of theta, we can represent it as dy over d theta and dx over d theta. Now, we could go through this product rule to get to our derivative, or we can find a way to create y of theta and x of theta. If we can find y of theta and x of theta, or get y and x in terms of theta, then we can just find those derivatives and that will get us to these two. So we should be able to avoid the product rule as long as we can get our equations in the right form. Okay. Let's look at example 4. Find dy over dx and the slope of the graph of the polar curve at the given values of theta. So we want to find dy over dx. We want to be able to plug it into these forms here, but that will require us to find y of theta and x of theta. So let's see if we can get x and get the x equation in terms of just theta and the y equation in terms of just theta as well. So x equals r cosine theta. So this cosine theta will stay, but the r, we want to go ahead and see if we can replace that. Well, we know that r is given to us as 2 plus 2 sine of theta, and we can simply just make our substitution. So 2 plus 2 sine of theta times cosine theta. This represents x. I'm going to go ahead and distribute. So 2 cosine of theta plus 2 sine of theta cosine of theta. I'm going to use a double angle here to clean this up a bit so that I can avoid product rule in the future. So 2 sine of theta cosine theta can be rewritten as a double angle as sine of 2 theta. So here's my x of theta, my x equation, now represented in terms of the variable theta. Okay, let's move on to y. We're going to create y of theta. So we start off with y is equal to r sine of theta. R sine of theta will stay. R gets replaced with our equation. So 2 plus 2 sine of theta times sine of theta. Distribute that through. We get 2 sine of theta plus 2 sine squared of theta. So we're one step closer. We have x of theta and y of theta. So now let's find x prime of theta and y prime of theta. That'll get us to dy over d theta and dx over d theta. They mean the same thing. Dy over d theta, same thing as y prime of theta. Dx over d theta, same thing as x prime of theta. So let's first find the derivative. X prime of theta, we're starting with x of theta. 2 cosine of theta becomes negative 2 sine of theta. Okay? Sine of 2 theta, remember sine of u, the derivative for sine of u is cosine of u times u prime. So sine of u becomes cosine of u times u prime. The derivative of 2 theta is 2, so I can pull that out in front to make this 2 cosine of 2 theta. Okay. Now moving on to y prime of theta. So let's start with y of theta. 2 sine of theta becomes 2 cosine of theta. 2 sine squared of theta. Okay, so we have to go through chain rule here. So this is the same thing as 2 times sine of theta squared. So we bring down the 2. 2 times 2 is 4. 4 sine of theta times times the derivative of sine of theta, which is cosine of theta. So we bring down the 2. So it's basically 2u times u prime. So the 2 times 2 gives us 4. So 4 sine of theta cosine of theta. We have our x prime, we have our y prime. Now let's evaluate them at pi over 2. So x prime of pi over 2, just replace our thetas with pi over 2. So this gives us negative 2 times 1, which is negative 2. Cosine of 2 theta, so 2 times pi over 2 will produce just cosine of pi, which is negative 1. Times the 2 in front, so that's negative 2. Negative 2 minus 2 is negative 4. Y prime of pi over 2. Plug in pi over 2 and for all the thetas. and we get 2 cosine of pi over 2, which is 0. 4 sine of pi over 2, which is 1. Cosine of pi over 2 is 0, so 0 plus 0 is 0. So our dy over dx, our y prime over x prime, will simply be 0 over negative 4, which is 0. Okay, one more example here. Find the points r, theta of horizontal and vertical tangents to the graph of r is equal to 2 minus 2 cosine of theta. So 2 minus 2 cosine of theta, we know that this will produce 2 minus 2 will be 0, 2 plus 2 is 4. This will be a cardioid that is in symmetrical about the x-axis. So here's the graph of that, right? And we know horizontal tangent is going to be basically where our dy over d theta is going to be 0. Vertical tangent will occur where dx over, dy over our dy over dx is equal to 0 for horizontal tangent. Vertical tangent will be where dy over dx is undefined. Okay, so basically horizontal tangent will occur where my y prime is equal to 0. Vertical tangent will occur where my x prime is equal to 0, where my denominator is 0, which will cause the slope to be undefined. Okay, and we can tell by looking at the graph here, we will be expecting horizontal tangents to be at the angles that will take us to these points here. And our vertical tangents, we expect one to be here, here, and here. However, we have a sharp point here, so there will not be a slope of undefined vertical tangent here. So we have to beware of 0 over 0. Okay. All right, so let's see if we can build our way to y prime and x prime. So let's first start off with x of theta. We need to build this step by step. So x of theta is, well, we know x is r cosine of theta. We know what r is. R is 2 minus 2 cosine of theta. We distribute that through. We get 2 cosine theta minus 2 cosine squared theta. Y theta. Y is r sine of theta. Well, again, radius. We can replace 2 minus 2 cosine of theta. So we have y of theta, which I'm going to distribute, and I'm going to clean this up a bit to make the sine of 2 theta. We don't have to do that, but it'll just make things easier and less things to plug in. So we have our x of theta, we have our y of theta. Now we find our derivatives. So 2 cosine theta, 2 cosine theta becomes negative 2 sine theta. 2 cosine squared theta, go through chain rule, bring down the 2. Keep the cosine, multiply by the cosine's derivative, which is sine of theta. Okay, now moving on to y. So 2 sine becomes 2 cosine. Sine of 2 theta, sine of u becomes cosine of u times u prime. Now, horizontal tangent, this is where y prime of theta is equal to 0. So we set our y prime equal to 0. So 2 cosine of theta minus 2 cosine of 2 theta is equal to 0. Well, now we want to bring this out of the double angle so that we can factor and begin to solve for theta. So let's get this all in terms of cosine, since we have cosine here. So cosine of 2 theta, one of the ways that we can expand that is by saying 2 cosine squared theta minus 1. There's a negative 2 out here. I distribute that through. So I get negative 4 cosine squared theta plus 2 cosine theta minus, negative 2 times negative 1 is positive 2. So from here, I'm going to make my first term positive, so change the signs of every term. Divide everything by 2 to take out my GCF. So I'm left with 2 cosine squared minus cosine minus 1. Go through my factoring. 2 cosine theta plus 1, cosine theta minus 1. Set both equal to 0. Cosine of theta is equal to negative 1/2. Cosine theta is equal to 1. So when is cosine equal to negative 1/2? Well, cosine will be negative in the second and the fourth quadrant. So 1/2, these will all be variations of pi over 3. So in the second quadrant, it will be 2 pi over 3. And, cosine is negative in the second and third quadrant. So, and then the variation of pi over 3 in the third quadrant will be 4 pi over 3. Where's cosine equal to 1? Cosine is equal to 1 at 0 and 2 pi. So those are crossed out simply because we're going to have to eliminate them later. But for now, we have these potential points, potential angles. Hey, vertical tangents could be where the dx over dt is equal to 0. So we set dx over dt equal to 0. Let's see if we can get all this to be in terms of, well, actually, we can factor here. We can actually factor the negative 2 sine of theta out, leaving us with 1 minus 2 cosine theta. So these are in factored form. We can just set both equal to 0. Negative 2 sine of theta equals 0. Divide both sides by negative 2. Sine of theta is equal to 0 at 0 and pi. Okay. Where's cosine equal to 1/2 in the first and the fourth quadrant? So pi over 3. Variations of pi over 3. So pi over 3 and 5 pi over 3. So now we have to be aware of our 0 over 0. So basically anything that will cause 0 over 0 we have to eliminate. So we have to eliminate any duplicates. So 0 over and 0 we have to take out 2 pi. We'll have to take that out as well. That's basically 0. And now we have our vertical tangents occurring at pi over 3 and 5 pi over 3. Horizontal tangents will occur at 2 pi over 3 and 4 pi over 3. So now, once we have all those angles, we can just plug them into our equation for r, since we're trying to find the ordered pair, these polar points. So plug 2 pi over 3, we get 3. Plug 4 pi over 3 in the equation, we get 4 pi over 3. Plug in pi, we get 4. Plug in pi over 3, we get 1. And plug in 5 pi over 3, we get r of 1. So we have 5 points, 2 horizontal tangents, and 3 vertical tangents, just like what we suspected here. 2 horizontal and 3 verticals, 3 vertical tangents.